Hey everybody, this is Brian, and welcome to the 83rd Qt tutorial with C++ and GUI programming. We're going to kind of continue our little journey through the QGraphics view, and we're going to call this one animation. And as you might have guessed, yes, we're going to be doing a bit of animation. I have to apologize, it's been a while since I've done a video. Life's been just really crazy lately. I got very sick. Then we had a tornado. A lot of people didn't have power or running water, and the city I live in quite literally looks like a war zone right now. So it's been kind of a weird ride. Alright, now what we're going to do today is we're going to make a very simple animation, and it's also going to be a bit advanced, and it's very hard to find something that's simple yet advanced, and that's what I've been kind of striving here. So let's just dig on in and start working with this thing. So open dialog.h, and of course I am making the assumption here that you have been following along in my other videos, and if you haven't, please watch them before you try watching this one. You may get very lost very fast if you try to just watch this one. And we want Qt GUI. One bit of news is I'm actually rebuilding my website, so I'm going to have all of the source code for all the tutorials up on the website. So you could actually go to my website, and don't worry, there won't be a membership or advertising or anything really stupid like that. You just basically, you download the source code right after you watch the video, and you could watch the videos right off the website too. I'm going to link it back from YouTube. Alright, we want a QGraphics scene. Help if I could spell it right. Graphics scene. Here we go. Sorry, I just ran 3 miles today. I've been running on top of my normal workout regimen, so I'm a little slow right now. Just bear with me. And we want a Q timer, and we're going to say timer. And we're going to flesh this dialog out before we really do anything else here. Very simply, what we're going to do is we're going to have a QGraphics scene. We're going to add our QGraphics view here in a minute. And we're going to have a timer, and that timer is going to fire off and do something. So let's take our dialog here. Very simply just throw a graphics view on there and then tell it to take up the entire document. Then open up dialog.cpp. Now, what we want to do here is just very simply say scene equal new. We want QGraphics scene. Like I said, help if I could spell today. There we go. And we're just going to give it this as the parent. And then we're going to say UI graphics view. And we're going to set the scene. There we go, very simple. And now what we're going to do is we're going to do anti-aliasing. If you don't know what anti-aliasing is, it's a very simple concept. It just smooths out the graphics. And we're going to set render hint. And what this does is it tells the graphics view what sort of rendering we want to do. So we're going to say Q, painter, and anti-aliasing. And let me kind of scroll over here so you can see that. So we're just saying set render hint, QPainter, anti-aliasing. And you can look all this up in the documentation. I'm actually not going to explain a lot of these commands. I'm just going to whip through the code. And I really want you to grasp the concept, and you can go back later kind of on your own time and explore the documentation for each one of these things. So scene, and then we're going to set scene rect, and what this does is you can set the size of the scene within the view, and that's an interesting concept. We haven't really discussed this yet, and I'm going to show you what we're talking about here. You see I'm punching in some magic numbers. We're saying -200, -200, 300, 300. So what are we doing here? Well, you remember when we run this, it will show it with 0 being dead center. So we're saying -200, -200, and then 300, 300. And we're just basically making a big rectangle here. QPen. We'll call this my pen, and we're going to say QPen. And we're going to say Qt red. So we're just going to make a red pen here. And now we want to make a few lines, and we're going to actually draw out on this scene. I'll show you here in a second what we're going to do. It's kind of confusing to really explain. We'll say Q line F, and we'll call this top line. And we want to give this the location of the lines here. So we'll say scene rect, and we want top left. So what we're doing is we're saying the bounds of the scene rect that we just set here. The scene is within the view. We're using that as our locations for our lines. And this will become pretty obvious here in a second what I'm doing, but right now you're probably looking at the screen going, what are you doing? So bear with me. Because this is a more advanced topic, this is going to take a little bit of setup here. And you can see what I'm doing here is I'm going from the top left to the top right, and then just for the sake of speed here, I'm going to just literally copy and paste this line a few times. And then we're going to make a couple different line objects here. And what I'm going to basically do is make a box. And we'll call this left line, and then we'll call this right line. Now you might be saying, well, if you want to make a box, why don't you just do a rect? Well, I'm going to show you. What we want to do is we want to create a box and have our objects inside of that box. And so we've got top left, and now we need to do bottom right. Whoops, kind of screwed that one up, didn't I? Here we go. But that's really why I want to, whoops, not bottom right, bottom left. Sorry, I got a little confused there. And then this one we want bottom right. What I really want to do with the website, sorry, kind of got lost there, was I want to be able to have the source code on there so people can find it rather easily, so they don't have to retype all of this garbage. And well, I think you know the benefits of having the source code, so let's just leave it at that. But the website's half done. I'm hoping to have it done in another week or two. It's going to be all database driven, so you can search for things rather than poking around through 500 links and looking for them. Alright, now let me check my notes real quick here, make sure we got this all right. So we got top left to top right, top left to bottom left, top right to bottom right, bottom left to bottom right. So we're just basically making a box with a bunch of lines. Now we're not using a rect because in this tutorial we're going to be using collision detection. And so what we need to do here is scene, whoops. I totally misspelled scene, didn't I? Yes, I did. Sense. It's funny. No, I guess I didn't. There we go. Let's fix this. Misspellings bug me. And of course now this won't work right, so we've got to touch this up a little bit. Like I said, I ran 3 miles today. I'm very sorry. My mind's just kind of scatterbrained right now. And we'll add line. And we're going to just add top line. And we're going to add my pen. So we're just going to draw these lines out now. And let's just copy and paste these in here. I'm a big fan of copy and paste. The less typing I have to do, the better. So we're just adding in a bunch of lines. So let's save our work, run this. Uh-oh. Yep, see, that's what happens when we have a little bit of misspelling here. Not a big deal. We can fix this super quick. Once again, I apologize. It's been really crazy. Like I said, I got really sick for about 2-3 weeks. Then we had the tornado that ripped up the city, and life is just now starting to go back to normal. Not quite there yet, but it's getting there. Alright, now, tick-tock, tick-tock. Once this thing always builds, there we go. So what you see here is we've got our graphics view, and inside of it we have our scene. And you see these lines. And we see we can scroll, but let's pull this out. Now you can see how it's like 0, 0, negative 200, negative 200, 300, 300. That is how this works. We have our view. In the view we have the scene. And in the scene we have set the scene rect, meaning the outermost edges of the scene. And we've drawn these lines in here. We could have used a rect, but we want these lines because we're going to add objects in this box, and we're going to move the objects around and use collision detection. So we're going to add a box, and the box is going to move, and when it hits this wall, it's going to bounce back, and then when it hits this one, it's going to bounce back again and again and again. And then we're going to add a bunch of those boxes, and they'll bounce into each other and into the walls and all sorts of fun stuff. So now you kind of understand what we're going to try to accomplish here. Sorry it took so long to get to that point, but like I said, we had a little bit of setup to do here. So we're going to say timer equals new, and we've got to say QTimer. And we are just going to connect that timer. Whoops. Somebody actually contacted me and said they were going to make a rap video out of all the times I say oops. I think that's just hilarious. I actually want to see that if it ever gets done. He's like me, he just does no time, but I think it would be kind of funny. It'd be like oops, 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 or something like that. I know, don't quit my day job, right? Scene and like I said, if you have absolutely no clue whatsoever what I am doing, please watch the other videos. This is an advanced video, and unfortunately we don't have a lot of time to sit and explain every single little thing here. But I am going to explain what we're doing right now. What we're doing is we're creating a timer, and we're going to say, okay, this timer is going to run every 100 milliseconds. And we're connecting that timer, the signal timeout, meaning every time this timer ticks, to the scene's advanced slot. Now what does that do? Well, the scene has a slot called advanced, and what that does is it notifies every object within the scene that it's time to advance one step or multiple steps, because that's what an animation is. It's a series of steps. I mean, have you ever made your own cartoon in a notebook where you draw on a page and each page is slightly different, and then when you flip it with your fingers it animates? Well, that's what the concept of an animation is. You have multiple steps, and we got this timer firing off. Okay, so we have got the basics now for our animation. Now what we need to do is add our own item. So let's just right click, and we're going to add new. And this is just going to very simply be called my item. Help if I could spell item, geez. I am like typing challenge today, my item. And actually, let's just capitalize that, sorry. Like I said, it's been just one of those weeks. Alright, now we've got my item, and we want to add a few includes, and just for the sake of time I'm just going to copy and paste out of my notes. I've had a couple people write and complain that I spend too much time adding includes when I can just copy and paste them. So here we go. We're including QPainter, QGraphicsItem, and QGraphicsScene. Now we want the painter because we want to be able to paint. We're going to actually inherit the QGraphicsItem, and we want the QGraphicsScene because we want to be able to reference that back. So let's actually do our inheritance now. We'll call this public. We'll say QGraphicsItem. I had another person write in. I love hearing from you guys, so please keep up the feedback. It just kind of makes me smile every time I get a message. But he wrote in and said he laughs every time I make a misspelling because he does it like 9 million times a day. And it makes him feel good to see somebody else screw up. So now, based on our previous tutorial, of course we need to have a few items in place if we're going to inherit a QGraphics item. One of which is the QBounding rect. And that is, of course, a constant. And then, of course, we need our paint. And we can just, use IntelliSense to kind of fill this in for us here. And that just saved us a whole lot of typing. And now we want our protected. And there's advanced. Now you notice how it has this int phase. You could also call that int step or whatever you want, but that we're getting that from the timer. Remember, the timer is going to fire off on the scene. Let's pull up that dialog.h here. We've got that timer, and that's going to fire off the advance in the scene. But the scene's going to tell every object in it to advanced, and then how many phases or steps. And then we're just going to have a few private variables here. And we're going to make a QReal called angle, and another one we'll call speed. This is going to be the speed of our object, and we want a function do collision because we want to do something when the object collides with another object, right? Okay. Now we're just going to add these in. And of course you just right click, go to refactor, and then add definition to myitem.cpp, and it adds the code in for you so you don't have to type any of this stuff out. That's one of those hints I love. There's a bunch of hints people have been sending me in, and I'm really sorry. I just have not had time to sit down and burn them into memory. There we go. So now we've got our my item. Let's just give it a quick build, make sure we didn't screw anything up here. Once this builds, we can start filling it in, and okay. You notice how the only thing we have here is a warning, so we're good. Now, what we should do here, before we really step into this item, is let's back up and go to our dialog implementation here. Somewhere in here, before we start this timer, we have to add these objects in. So let's go ahead and throw our include in here. And we're going to include my item. And then we're going to just say int, and we will just call this item count equal, and we're just going to add one item just for the sake of argument. But then we're going to say for int I equals 0, and we're just going to say, you know, I is less than item count on I plus plus, because what we're going to plan on doing is adding a bunch of items, but we want to be able to change that kind of on the fly here. So we'll say my item and if you're wondering if we're creating a memory leak, I don't believe so, because we're adding this into the scene, and the scene takes care of that pointer. I've had a couple people contact me about memory leaks, and that's actually, you know, I like it when they contact me, but Qt handles memory very well for you. So a lot of things that may look like memory leaks actually are not, because it's all handled behind the scenes. Because we're passing this pointer off to the QGraphicsItem item, it is now in charge of that pointer, and I believe when that is destroyed, it destroys all the pointers, or I should say it deletes all the memory too. Alright, so now we've got that, and really all we're saying is for however many items added to the scene. Now, we're going to look at the constructor here, because this is going to be the meat and potatoes of this item, is this constructor. What we want to do is accomplish a few things. We've got our item, and we want a random start rotation. Whoops. We want to start this object off at a random axis. We also want a random start position. Why do we want this? Well, if we're going to add a bunch of these, we don't want them all starting in the same place. We're going to have a billion collisions going off at the same time. Now, let's actually just flesh out this object really quick here. Remember from our previous tutorial, the bounding rect is the outermost region of our object. So we're just going to say 0, 0, 20, 20. So it's only going to be 20 pixels wide, 20 pixels tall. And then of course we have our paint, which we are going to just quite simply paint this object. So let's just say qrect f, and we want the bounding rect. So we're just grabbing the bounding rect, which is this 0, 0, 20, 20, and then we're going to say qbrush, whoops, qbrush, yeah, that's a good one, qbrush, and we're just going to call this brush. And we're going to just start off with gray here. Whoops. We're just going to start off with a drab gray. And what we're going to end up adding here is some basic collision detection. And what we're going to say here is if scene, and we want to know colliding items, and you notice how the scene tells you what items are colliding, and we want to know if this is one of the items that's colliding. Whoops. but we want to say is empty, meaning we want to know if this item's colliding with anything. And if it is empty, then there is no collision. Otherwise, collision, and then we'll just add a few exclamation points here. So that's how we do basic collision detection. The scene is going to tell us, remember we add this object into the scene. The scene is going to tell us where the objects are, and it's going to say scene colliding items this, meaning we're going to say is this item colliding with anything? And it's going to return is empty, means no collision. I know that sounds kind of convoluted, but what we're going to do here is we're just going to say brush dot set color, and we want cute green. And then if we have a collision, we want to do brush set color, and we want to say cute red. And if there's also a collision, we want to call this do collision command down here, because we want to do something when there's a collision. And what that is going to actually do is set the new position. And the problem I had with this tutorial trying to really build this thing is I want it to be an advanced topic, but at the same time I want it to be easy to understand, and that is an extremely hard combination to find. And so what we're just going to do now is we're going to fill the rect, and then we're going to draw the rect. Oops, draw rect. Alright, now that's our very simple object here. You notice how we have not done anything in the advanced yet, and we have not done anything in the collision detection. So let's actually go ahead and do something here. We're going to say if not phase, meaning if there's no phase, return. Because what may happen is it may call the advanced function and there's no phase, meaning it's not doing anything, it's just calling it. And we're going to say qPointF, and we want the location. And we want this dot pose. I mean, we want the current position of this object. We want to know the point in space where this object is. And then we're going to say set pose, and we want map to parent. And what map to parent does is it maps the current XY coordinates to the scene's XY coordinates. Alright, so now we've got this map to parent, and we want 0, and we want to minus the speed. So what we're really doing is we're saying set the position, and we're going to map it to the parent coordinate systems, 0, and then we're going to minus speed. And speed we have not set yet. Remember, we have a lot of stuff to fill in the constructor here, which we haven't done yet. So what we're going to do here is we're going to say start the speed. I should say set the speed, not start the speed. So we're going to say speed, and we're just going to say 5. So this thing's going to go 5 pixels at a time. And then we want to set the start position, and we're just going to say actually let's focus on the angle here. Sorry, I kind of scatterbrained. I'm going to say angle equal, and we want to make a random number. So what we want to do here is say QRand, which you guessed it makes a random number, and we give the modulus of 360. So meaning it's going to do between 0 and 360. It's going to make a random number. And then we want to set rotation, and of course we want the angle. So we're just going to say, okay, give this start rotation a random number between 0 and 360. So we're just going to spin it around, set the rotation of the angle. We're setting the speed to 5, meaning it's going to go 5 pixels at a time. And then we want a random start position. And we'll say int start x equals 0, and int start y equals 0. And then we're just going to say if, and we want to make a random here, so we're going to say QRand. and we want the modulus of 1. So basically what we're doing is randomly saying true or false, is a very simple way of putting that. So if it's 1, then what we're going to do is going to say start x equal, and then of course we're going to do another QRan. We're really trying to make some random stuff happen here. Percent 200. So we're going to grab a random x location between 0 and 200, and a random y location between 0 and 200. Otherwise, what we're going to do, if it's not a 1, remember it's going to be random between 1 and 0, is we're going to say negative 100, negative 100. So we really got a whole lot of randomness going on here. And let's review super quick. We're setting a random angle. We're setting the speed. Notice the speed's a constant. Or it's not really constant. We're just not making it random. And then we're setting a random x and y. So then we're going to set pose. We're going to set the position. And you guessed it, map to parent, because we want the parent's coordinate system. And we're just going to do start x and start y. Alright. So we've got our constructor, we've got all this randomness going on here. We've got our bounds, so we're 0, 0, 20, 20. And then we're painting this thing. And then we're advancing the position during the advance. But we're not doing collision detection just yet. What I think we should do at this point, just save this, let's build and run, make sure there's no little bugs. And watch this thing for just a second here. See, there's our little block. You see how it turns red when it hits that line, and then it just keeps going and going and going off into space somewhere. See, there it goes. Because we have no collision detection. Now, if we had made this erect, let's actually run this again. I know that went fairly fast. See how it's green? And now it's red, and now it's green. If we had made this erect instead of lines, it would be red all the way through, because it's colliding with a rectangle. That's why we made the individual lines. Now we need to do our basic collision detection here. So in here, what we're going to have to do is we're going to have to say get a new position, and we're going to change the angle with a little randomness. Because we don't want to always turn the same way, same direction, same everything. We want this to be a little unique each time. So if, and you guessed it, QRand. So we're just getting a boolean, you know. And we're going to set rotation. And we're going to say rotation. Rotation gets the current rotation, in case you're wondering. And then we're going to just say 180 degrees, so if it hits something, we're just going to spin it around, plus we're going to add a little, what's the term in pool? English. So we'll say QRand, and the modulus of 10. So really all we're saying is if it hits something, we're going to spin it around in the opposite direction, and then we're going to add anywhere between 0 and 10 to the angle. And if it's not that, then we're going to move it in the opposite direction. You know, positive number goes clockwise, negative goes counterclockwise. So we're just going to basically randomly change between clockwise and counterclockwise with, you know, a 10-degree angle. And then we're going to see what happens here. And let's run this. See, there's our ball. Oh, you notice how it kind of freaks out there? And it just kind of got stuck on that line for a minute. It means we need a better algorithm here. And you notice how it just went out of bounds. And now it's going off into space. So as you can see, it's not just as simple as doing a little collision detection. Now what we've got to do is do some error checking on top of that. So we have to see if it's in the bounds. So what we're going to do here is we're going to say QPoint, oops, not QPaint, and we're going to say new point, equal map to parent. And what we want to do is actually bounding rect dot width and then we want to bounding rect dot width plus 2. So what we want to do here is we want to see if this is within the bounding rectangle here. Seems I've fudged something up. I bet it's missing one of these. Okay, when all else fails, I'll just copy and paste from my notes here. There we go. So we're saying new point, map to parent, and we're going to make the bounding rect width a negative number, and then bounding rect width plus 2 a negative number. So what we're doing is we're really saying where it's at, move it. And we want that plus 2 because we want to push it away from the object that it's currently colliding with. I know that seems kind of convoluted. Bear with me, I'm checking my notes, make sure we're on track here. Yes, we are. Alright. So now what we want to do, if not scene rect dot contains, and we want the new point. So what we're saying is if the scene rect does not contain the new point, then we need to do something about that. And for this, we're just going to move it back in bounds. Whoops. Else, set the new position. So we're going to set that. Whoops, there we go, new point. Map to parent, and we're just going to say 0, 0. Throw it back in there. Alrighty, now save our work, run this. And see our little bouncy ball, and you see how it now bounces. And we're just going to watch it here for a second, watch it kind of bounce in and out of these lines, and you notice how it just kind of goes back and forth, back and forth. And when it hits, it doesn't just go back the same direction, it actually kind of randomly jumps around here. So that's pretty neat, and you can see how the edges are kind of smooth. That's the anti-aliasing. The reason why it's not turning red is because it's a pretty small object. If we actually beef this object size up a little bit, let's make this like a 50. And also that timer is firing off pretty quick, so let's beef this up a little bit. There we go. Yeah, you can see it kind of bouncing in and out. I don't know if the video is catching the red or not. It's pretty fast on my screen. Let's set this back to 20. And what we want to do is we want to really quickly review this code because I want you to really understand how this is working here. So let's just close everything and go back to step 1 because I got a feeling we flew through this pretty quick. We got our dialog. In the dialog we have a graphics scene, which is part of a view, and a timer, and that's firing off. Every time that timer fires off, it calls the advance slot in the scene. That scene then notifies all the objects within the scene. And we're firing that off every 100 milliseconds. And we've got one item. Let's actually change that to... I need a random number here. Anybody tell me what we should change this to? I'm looking at my cat, and the cat's just kind of staring at me. It's a little creepy. Let's just say 25. So we're going to add 25 of these little bouncy balls in here. And then we've got our custom item. And in that, of course, it's just a QGraphics item where we have the bounding rect, we have the paint, the advanced, angle speed, and do collision. And we've implemented that we've got a little bit of randomness at start. We're setting a random angle, setting the speed, and then we're setting a random start location. And then we're just setting in the position. We're setting the bounds, and then we're painting the object. And what we're doing is some basic collision detection here. And what we're saying is, you know, if there's no collision, it's green. If there's a collision, there's red. And then do collision, which sets the position here. And during this, what we're doing is we are just map to parent 0 speed. What that does is it says move it speed, which is 5. So we're doing -5 for the Y. So if you had no angle, this would just drop straight down, but because we're setting a random angle, it's going at a different angle. I know that sounds confusing, and I'm sorry. Do collision, which is where we're doing our collision event. And what we're doing is we're just getting a new position. We're changing the angle with a little randomness. We're, you know, making it go complete reverse and then adding a little 10 degrees to it. Getting a new position, and then we're making sure that it stays within the bounds. So let's see what this looks like with 25 of these little guys. Oh yeah, you can definitely see them colliding now. And you can see how whenever they collide, they turn red and they kind of bounce back and forth. And if you did not have that collision detection, what I saw when I was running this the first time is they would, for the most part, stay in bounds, but once in a while you'd have an escapee that would go way out into space somewhere. Now, granted, this is not a perfect example. There are bugs in this program, as there are with every program. But what I wanted to show you was how easy it is to do animation with Qt, but at the same time, just how complex animation really is. So next time you play a video game or you see a screensaver or something, you should realize there's a lot of stuff going on under the hood and a lot of solid math that's really going on. So, anyways, this is Brian. Thank you for watching. Keep up on that feedback. I love hearing from you guys. And like I said, I am actually spending most of my time working on my website because I want to get the source code up there along with the videos and a whole bunch of other good stuff. And no, there won't be any cheesy advertisements or banners or join now or any of that garbage. It's just going to be my website. So, all right, enough of me talking. Thanks for watching.